Hi, I'm Dr. Eschenberg, and I teach introductory physics. In all of the classes that I have taught, which were physics, I also teach algebra too, but in all the physics courses, I begin with the following exercise. And thus it has begun. The first thing I like to do is get students to ask questions. It increases involvement between the professor and student. I encourage questions. I get very bothered when they're quiet, when they don't say anything. And so I open up with this, and I said, I want some basic questions. A lot of people go, well, what color are they? Why are they there? And I respond, that's either a too complex question, or as to why are they there, that's philosophy. It's not a physics course. But there are 4 fundamental questions that this stuff answers. And the first of them is, where are they? They are in Oxford, Mississippi, Lafayette County, Mississippi, United States, North America, planet Earth, Sol system, and so on. That's the first question. The second question is, how many are there? And so you could sit there and just take a look, say, oh, there's 6 of them. The next question is, how much of it is there? And like this die here has a little more stuff than this die here. And they're all got a lot more stuff than that die right there. And so the quantity of stuff is important. And then the last one, and this one gets the how much of it is there tends to be a rare question. The really good question that almost no one guesses is, when are they there? That right now, 6:45 p.m., April 20th, 2020. That's when they are. Because at 6:46 and 10 seconds, there are 6 there. A couple seconds later, there are only 3. So there's the quantity of when. So where, how many, how much, and when. With physics, we like to quantify, describe, value, or just take a look at how things work. And where answers the fundamental question of position. How many are there represents the count. How much of it is there represents the mass. And when are they there represents time. And with these questions, you can start describing the world around you with this stuff. Now, on the planet, there are 2 major systems of measurement. There is the Système International, which some people call the international system. Some people shorten it to SI. Other people call it, or most people call it, the metric system. And then there is the imperial system, The metric system is used by the vast majority of the countries on the planet. The imperial system is used by America, us, and a few other countries, not many, like 2 or 3. I tend to be, I was raised as a particle physicist in my graduate school education period of my life. I believe in the metric system. I think it is important. I think it is superior to the imperial system. The problem is that America has momentum in using the imperial system. In an episode of The Walking Dead, the little kid was trying to do a math problem, and the airplane was its velocity was in miles per hour. And I'm like, it's the perfect opportunity to switch to the metric system. Why? Because all the infrastructure is gone. Just suck it up, clean off the zombie guts off everything, and just start using the metric system. It is just better than anything the imperial system has. Now, we're going to teach both. And when it comes to and I'm going to start using the fundamental units, like for count. In the imperial system, we would use like the dozen. A common metric term is a mole. Whereas a dozen is 12, a mole is 6.02 times 10 to the 23rd. And we'll get into what the 10 to the 23rd is in a little bit. Now, for position, imperial system, we use either the foot, which we could just use F, or we use the mile. Metric, we use meter. For mass, we use the pound. In the metric system, we use the kilogram. In time, there's no such thing as metric time, thank goodness. I think they tried to use it in the 1950s in France, but I'm not sure. Second is used for both. And when it comes to this stuff, when you see these brackets, that's kind of like a substitution or abbreviation, or what units I tend to use when I initially use them. So mile, we use MI. Meter, we use M. Mole, we use MOL. Dozen, we use DZ. Pound, we use LB. Kilogram, kg. Second, we use S. Okay. And so when we're going to learn, dial it back, Vance. We're going to initially use a mix of metric and imperial, but eventually we're going to switch to metric and stay there. So we've got all these initial units, and when you use these units, and we'll start working with the metric system, if you express your answers using the units of kilograms, meters, and seconds, you're fine. Can't go wrong with that. Those are 3 fundamental hardcore units. Mole, that's just for the chemists that are watching this video. Mole's okay, and I'll use it from time to time, but it's not everywhere. So with these two things right here, kilogram and the mole, and notably the 10 to the 23rd, these two boxes, the one that's to the upper right is the superscript. The one to the lower right is the subscript. And they are used to convey either mathematical ideas or descriptive. The subscript tends to be more descriptive. The superscript tends to represent the power of what's going on. Now, to get to the whole idea of the superscript and the power, we have the idea of like 1, 10, 1,000, 1 million, and it starts getting a little bit tiring to sit there and write all these numbers. 6, 9, that's about as far as I need to go. 0.1, 0.001, 0.000001. Oh goodness. 0.00000001. Writing these numbers and writing all those zeros out is tiring. And what we use now is like the scientific notation. Now, for 1 and 10, 10 to the 0, 10 to the 1, I mean, that's not very useful. But what this is showing is that you have a 10 with no zeros, or 1. You have a 10 with 1 0, so it's 10. And when you get to 10 cubed, that's 1 followed by 3 zeros, 10 to the 6th, 10 to the 9th. And really what you're saying is that I've got a 1 followed by 9 zeros. This is 10 to the negative 1. So now you start seeing those negative signs. That represents a number, a fraction less than 1. 10 to the negative 3, 10 to the negative 6, 10 to the negative 9. And so it's a lot easier to write this than this nonsense. Now, the second part is this whole idea of kilo. This is an advantage that I think that the metric system has over the imperial system. You can just look at the symbol, listen to the word, and you can tell what you're dealing with. If you've got 1,000 of something, like 1,000 students, you use kilo student. And the other analogy that I'm going to use, or example that I'll use, are like bytes in a computer. And you're very familiar with the bytes. Kilobyte, size of a small file. 10 to the 6th, mega. 10 to the 9th, giga. Then you have others that are even bigger than that. You've got 10 to the 12th, tera. And so since we've all used computers, we're familiar with megabytes, gigabytes, terabytes, and that's what it represents, like a certain number. And if you got a terabyte of data, you got a lot of data. Now, on the other scale, the smaller numbers, you've got deci, milli, micro, and nano. Deci, you use little d. Milli, you use little m. Micro, you use this. This is a Greek letter mu. It is the Greek letter for M, which is what we use, the Roman letters. And then 10 to the 9th, we use nano. And the interesting thing, I write deci here because you're familiar with the word decimate. It's now meant to mean just utterly destroy. But its literal meaning, deci, 1/10, mate, to kill, to destroy. So decimate means to kill 10%, to destroy 1/10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, dead, and then keep on going. And in the metric system, everything is based on 10. 10 kilograms, 10 meters. And then when you start seeing the conversions in meters, moles, kilograms, seconds, etc., you can see that everything is base 10. Whereas 12 inches per foot, 5,280 feet per mile, stuff like that. This is the first step. And I bring this small little demonstration or lecture to introduce the idea that as a physicist, you have to learn to ask questions. At the beginning of the lecture, or these lectures, I'm going to help you answer questions. And then as the semester progresses, I'm going to start encouraging you to ask questions and then answer them yourselves, because that's for a good student, you answer questions. For better students, you ask your own questions and then answer them. And so this is kind of like the first lecture that I'm going to do. I'm going to set up my YouTube page. Eventually I'm going to switch over to live lectures. I'm going to have a subreddit. I'm going to do all sorts of crazy things, because this is my life. This is who I am. I am a teacher. I'm a teacher of introductory physics, calculus, algebra, statistics, microeconomics, macroeconomics, all sorts of crazy things. And I even help people with biology. So I'm willing to jump into a pool of unknown material. Why? I'll answer that later. As for right now, give this video a like. Please hit the subscribe button, and we'll talk again soon. Bye.